Hey everyone, PJ here. A tutor on Wyzant asked, how can I explain slope-intercept form to a student who keeps mixing up M and B? They say that their algebra student confuses the slope and y-intercept in y equals mx plus b. Even though they can graph and solve, they don't remember what m and b represent. What visuals or real-world examples have helped your students internalize slope-intercept form? So what we know here is that the student is algebraically strong. The student can look at a specific value of y equals mx plus b, and you can give them a set of axes, right? And they can plot for you whatever this looks like based on values of x. They can go down the values of x and quickly evaluate, oh, here and 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 here. It must look something like this, and they can plot very effectively. That's what I'm hearing. And they can also solve, which means they can solve linear equations. So they're algebraically pretty strong for Algebra 1, but they are going to be required to know more than that. They need to understand this conceptually. They need to know what M and B represent as mathematical objects. And this has to do with forming a intuitive understanding, more than just an algebraic muscle, but an intuitive understanding of what this equation really represents when graphed, but also just what it represents conceptually. So I'll explain the two. I'm going to explain with this analogy of a man, and my drawing skills are not fantastic, but I have this man, and let's say he starts at town A, and he's walking toward town B. And we have this little path that he's walking down, and this is his destination. We'll call this equal to 0. We'll say that he's starting at 0. And B is however long. It doesn't really matter for this analogy to work. M is going to stand for our man, because it's going to be the size of our man. And B is however much, plus B is however much he's walked toward B. Toward the town called B, right? From A to B, this is toward B. So M is our man. X is the number of steps. And Y is our distance. So if we think about it like this, I know I've labeled a bunch of things. It's a bit gibberishy, but it's going to start to be very clean once we graph it. Using this analogy, I have a man traveling down this road. Let me just change it to a solid line here. Oh. Doesn't want to. Okay, then. There we go. So a man is walking down this road, and let's say it's an average size man. So for every step he takes, he is moving 1 unit of distance. So for every X, he's moving 1 Y. So here we have Y is equal to 1 step, because this is a normal size man, so 1 is the size of a man. Y is equal to X plus 0, because we're starting to measure him at 0 here. And then let's say we start changing the size of our man. We start changing this 1 into different things. So maybe it is less than, right? Less than 1. Let's say our size of our man is less than 1. what that's going to look like is that our man is going to need more steps, more x, to get the same y, and our line is going to flatten out. So our slope is going to change because the size of our man is getting smaller and smaller, so he needs to take more steps to get where he's going. If the man gets bigger, if x is greater than 1, then we are going to see that our man needs to take fewer and fewer steps to reach the destination. Eventually, he gets there in 1 step, right, wherever he's going. But you can keep making the man bigger and bigger and bigger, and eventually he'll be able to step as far as he needs to step to get to where he's going. So this is the m part of the equation, the man. Let's look at the plus b here, mx plus b. So let's look at this plus b. This is the distance toward b that the man has traveled. When we start counting, so we're going to start counting. We're going to move this little guy here. We're going to move him halfway to B. And then we're going to start counting his steps. So what that looks like is we haven't counted his steps yet. So he's got 0 steps, but he's already halfway to the distance. So the distance he's going to cover here to get to B is going to be much shorter, right? He's already going to be halfway there. So it depends on where this little man is. If I just delete this and delete this, we can move our little man, back. And that would put him before 0 in distance, because this is our town A, right? We can move him further away from B than town A is, and then we'd start at 0. So if we say that this is toward B, we can make this whatever we want and start counting wherever we want, and that would move this up and down. So that is why plus B has to do with where it intercepts the y-axis. I hope this makes sense as an intuitive model for understanding y is equal to mx plus b.